I'll kick it off with some of the reasons why we started working on the AFX project and what the goals are and what are the capabilities. And like we said, go a little bit deeper. And now I have my partner in crime, Pranoop, to go way, way deeper. So let's go with the show. So why? Why did we embark on this project called AFX, right? Number one reason was that 2 years ago, we foresaw that with the evolution of the GPUs, that the way at the time, the current HA architecture on ONTAP will have trouble taking us for the foreseeable future. The advancements and timing of those advancements on the GPU in terms of performance and the scale requirements was way, way rapid than the normal evolution of how we evolve our storage hardware. For instance, if you look at NVIDIA GPUs, right, approximately 1.5 year cycle, they increase their performance 2x. If you look at the storage side, the storage industry hardware refreshes take around somewhere between 3 and 5 years. And when we do a refresh, the performance increase hovers around 35 to 80%. So there's an offset there, right? Now, with the current architecture that we had on ONTAP with the HA pair, that meant for our customers to add in more nodes, more shells because they're coupled together. And the outcome of that will be kind of off balance and made our customers pay more. So we need to do something about that. The other thing is we also saw that initially when LM training and foundational training was all there, it was all about scale and performance. But also when we looked into enterprise AI, those enterprise AI customers saw more value in terms of data management, all the rich data management that we currently have on ONTAP. So that's the other element. And the third is, of course, security and multi-tenancy that ONTAP provides. So those were the background that we saw with the AFX project. And now, yesterday, we announced the AFX. It is a new architecture from an ONTAP point of view and also new hardware offering. Unlike the traditional ONTAP offering, this, from an architecture point of view, it disaggregates between the controllers or compute and the storage nodes, like Jeff Baxter mentioned before, that allows our customers to scale independently. Now, if you take that notion and think about the GPU evolution that I talked about, a customer can buy the latest and greatest NVIDIA GPUs in year 1. They upgrade in year 2. NVIDIA comes out, double the performance. Then your storage evolution is 3 to 5 years. So what do? Right? In this case, it's disaggregated. What it allows you to do is, okay, if that is the case, then I just add more controllers or compute to keep up with the performance requirement of the GPU. And vice versa is also the same. Let's say you're starting out with a small amount of capacity and you're increasing your AI applications or whatnot, and you need more performance, more capacity instead of performance, then you could add more disk shelves to increase your capacity independent of your compute. So that's one. Yes?
So this means that when you said that it's new architecture, and you said it was new something else.
New architecture with new set of hardware offerings.
New hardware. So that means that if I'm a NetApp customer, and I want to take advantage of this, I have my normal storage sitting here, but then I have this additional piece of storage that gives me the AI functions over here.
Correct. That gives you the scalability and the performance and the other AI functions, right, with AIDE that resides with the AFX. The more important part there is, yes, there are two different hardware products, like the AFX. We call it AFX because it's a different series of set of products. The important part is, where is your data, right? You have your data on your, let's say, on your existing AFF, right? And you deployed your AFX system. Because they're running the same ONTAP, you could use all the ONTAP features and functionality between the two, like SnapMirror, like SVM Migrate, like FlexRoot, et cetera. All the replication technology and all the data management capabilities are uniform and compatible between the two systems.
Can I add AFX nodes to an existing cluster?
You cannot, because the layout of the storage and how the compute or the controller scale requires a different set of software architecture below. So that is not possible. That's why we focused a lot on the unification of the feature and feature parity between the AFF and the AFX, because they're all running the same ONTAP.
So are you going to get into like use cases of when we would use an AFX versus, I know like it's this high level AI thing, but I'm like, why can't, if I've got the GPUs and I've got everything else, why can't I just keep it on my regular old, why do I have to change platforms?
Yes, you certainly can. And we have a lot of customers using our AFX A90 for AI use cases, because prior to our announcement, AFF A90 was the only SuperPOD certified ONTAP device that we had, right? So in terms of the differences and positioning between our unified or our AFF versus block only versus disaggregated is as such, right? Unified or the AFFs that we have will be the bread and butter that caters to majority of the use cases that we have. And it has a bunch of different series of hardware products in there to cater to very small to very large, right? That will be our bread and butter. And you might have heard of ASA, our dedicated block devices, right? So that will stay. And disaggregated will be unstructured data only. So file and object that caters to more of a high performance, high scale type of use case, including AI, or one might expand to use cases for EDA, for instance, or M&E.
And
right?
just to
Go ahead. Yes.
I was just going to say, just to confirm, to work with the data, sorry, that data has to be on the AFX, correct? Can it work with the data that's already on the AFF, the AI data engine?
AIDE. For AI data engine question, I think the next session is the AIDE team. I think that's a better question to ask them, right?
I think I could simplify the question. If I've got data on a unified cluster, I can snap mirror it to the disaggregated cluster. Yes, right?
Yes.
So that's one way to integrate it. But am I correct in also assuming that if I start a cluster with one of these modes, I must continue, that cluster is going to live as a unified, that cluster is going to live as a dedicated block, that cluster is going to be disaggregated. There's going to be 3 different cluster types.
3 different personalities.
In those personalities.
Yes.
And that's it. You're not going to mix them.
No.
And for obvious reasons, but
Yes.
I want to make sure that's clear.
Yes.
That was simplifying the question.
For a NetApp tuned person, yeah.
Yeah, one of the questions that keeps coming up for me is, okay, I've been a NetApp customer forever and ever and ever, and I have lots and lots and lots of historical data, which is the stuff I want to use to power my AI journey.
Yes.
So would I just be snapping those over to the disaggregated personality? So I'd have 2 copies of the data, my old historical version that's maybe not even on a NetApp, maybe that's in Iron Mountain and I have to come and get it and restore it to the NetApp, and then snap it over to the disaggregated side, and then I've got the 2 copies, and at least.
Yeah, at least if it's definitely if it's a third-party non-NetApp, then yes, you will have to kind of migrate it over to an AFX and let the AIDE do its job of categorization. And from there on, then you could see the benefits of reduction of the copies of the data.
Okay.
Right. Okay. Any other questions? All right. So let's move on to the goals of AFX. The first goal was to eliminate data silos. What do we mean by this? We talked about this: independent scale, independent scale of performance and capacity, right? What we did here is, for those of you who are used to NetApp, is we have something called shelves, RAID, aggregates, right? And on top of those aggregates, we have volume. So we had a hierarchy of kind of containers that consists a storage container, right? What we're doing with the AFX is we're eliminating significant amount of those. So we're getting rid of the so-called aggregates, and we're going with an architecture that provides you the so-called single pool of storage. So all the storage capacity, disks, and shelves that you attach to an AFX will represent itself as a giant single pool of storage, right? The other part is what we mentioned before, is the ONTAP interoperability. We want to maintain all the data management and feature capabilities that ONTAP has and have those supported on AFX as well so that we could hit close to 100% feature parity. Third is future-proof storage. So this is the first release of AFX, right? We have a lot of plans to enhance it in many ways that we see that caters to an AI workload or any high-performance workload. Then we will start disclosing them as we get closer. But in terms of storage efficiency, in terms of new drives, in terms of metadata operations, those are the key areas that will continuously evolve. And also, absolutely, we do not forget increasement of performance and scale, right? We will continuously increase that as the releases goes on and on from the first release.
Okay, so now you said it, future-proof.
Yes.
If ONTAP is the current unification point, can you give me the date that AFX becomes the unification point?
No, right?
I'm being asked.
Yeah.
I mean,
Yeah.
like, is that something you could see, whether it's AFX functionality moving down, maintain the ONTAP brand, or
Yeah, so if
engineers
you,
smiling?
Good question.
from a feature functionality point of view, disaggregate sounds awesome. But if you look at the workloads
I don't
and
know,
how,
I'm sorry to interrupt. As a unification point, right? Do we shift the APIs out or allow for, right now, ONTAP is a single unification point, limited functionality, so to speak, in comparison to what AFX can do. But you could move some of that up with a pass-through, or there's a lot of ways that you can potentially, with a lot of really great engineering, turn AFX into a unification point. Or some other way in which this doesn't become such an issue architecturally of, I want to keep using my existing stuff, but I want to add functionality.
So from a feature functionality point of view, right now, it's when we, now since AFX is released, when a feature is developed, it's developed on ONTAP. So the goal is, and the objective is, to have it on all, not one or the other, right? So that's the benefit of having a single storage OS, right? You don't have two separate ones that I have to do this on this version, I have to develop a complete separate one in there. So that's the benefit. In terms of where that total unification, eventually will happen, I think that's kind of out there. We don't know yet, to be honest, right? Because there are benefits of disaggregation, and there are, use cases where disaggregation does not make sense. Especially right now is smaller deployment kind of workloads, right? Disaggregation there does not make sense because that's perfect for an HA pair architecture, right? Now, one can say, well, you could pare down your disaggregation to make it an HA pair. Yes, technically that is doable, but the challenge there is that going to be cost effective at this point in time from a dev, test, and et cetera, right?
It's really in the context, though, of future-proofing.
Yes,
This could be important.
yes. So in terms of,
I'll answer when I cover
yeah.
a few slides, right? On the
Great.
Yes.
Is that why you were smiling? Because I'm
Yeah.
prefetching your slides? Okay.
When you said some word there, I said, okay, I smiled because a lot of my engineers ask the same question.
yes.
Okay, good. Thanks for that
Okay,
straightforward answer.
all right.
I just have a couple of quick questions.
Sure.
So, NetApp's just over 30 years old now. ONTAP's been through a significant number of modernizations and things already, but in approaching AFX, how are you handling some of the constraints of technical debt and legacy decisions? Because there will be some, any code base that's 30 years old is going to come with a number of pieces of technical debt, decisions that were made that were great for the time, but you wouldn't make again now. And how do you balance that?
I think the easy way for me to answer that is top-down view, easy button first, right? Things like, SAN. We made a decision not to support it because it was not needed for the workload, right? Or other features that we see that has one of the highest technical debt that we had with this new architecture is elimination of aggregates going to a single storage pool, right? So those kind of areas, we looked at it with a magnifying glass in saying that, is this feature that ties to an aggregate that needs to move over to a single storage pool? Is this required? If so, how urgently? Or is this something that has a replacement feature already on hand for us that we will elect not to do? So we went through a series actually a long series of prioritization to make that decision and started executing on it.
I think that probably answer is somewhat contradictory to what he was asking, which is, hey, when is that unification point for every workload, right? And I think it's an interesting question, right? I mean, we have to start with a growth workload, right? I think AI is a growth workload. AI is going to be in front of every other workload that we have seen for the last 20, 30 years, right? So we have to make tough decisions to start with, but eventually it'll all come together, right? You know, hey, we're optimizing for throughput on the disaggregated, we're optimizing for latency on the block, right? So we have to make some decisions there, right? Are we going to do something like Metro Cluster going forward, or are we going to bring in another zero RTO solution that is much more flexible, much more granular, right? So these are the decision points we need to make and sort of move forward. Creating these two personalities of products will help us actually make those decisions better, right? And not confuse like existing customers versus new customers.
Thank you.
Okay. So let's kind of double click into kind of each of the key areas that or the benefits that the AFX provides. Number one, as we said, independent linear scale in terms of performance and capacity. Because it is disaggregated, you could increase your node or increase your capacity independently based on your needs, based on your workload, based on your budget, whichever way, right? And one of the things of the benefits with the architecture is when you start adding something, when you start adding, let's say, more capacity or more nodes, the system now has the intelligence to rebalance them as they get added automatically. You do not have to kind of manually go in and try to kind of offload your kind of volumes or whatnot from one node to another, because now this is disaggregated, different architecture with a single storage pool. The system knows about all the components that you have from a controller and a shelf point of view, and they will automatically distribute the load as it comes in. Yes.
Are you spreading volumes, since I'm assuming we're still using flex files as a unit of measure, across all the disks in the disk pool, or are we still bound to a physical aggregate underneath some virtualization layer? Just to be clear from before.
So let me answer that from a more of a one layer down.
Okay.
So all the nodes will see all the drives.
Right.
Number one, right? And on top of that, the default for AFX is not a flex file, it's going to be a flex group. And by notion of flex group, it spans out, right? Now, if the customer elects to do a flex file, yes, they can create a flex file, but the default will be a flex group in this sense, right? So flex group works beautifully with the new AFX architecture because its flex group is a capability that utilizes all nodes and spreads the constituents, the volumes out, right? So by default, flex group is configured, then it will see all the nodes and it will see all the capacity, and it will spread it out that way.
Yeah, but now that you disaggregated at the controller and the storage level through switches, you don't need to have secondary paths for that data. You don't have to have the non-optimized paths anymore, I guess, right?
Yeah, it really helps on that one, yes.
So that's true. That's correct. That now every node will have primary access to its own data. That's pretty cool.
Yeah. Okay. Now, in terms of performance, because again, it's disaggregated and we built it so one of the key goals is, yeah, when you add your more controllers, the performance increase must be linear, and we have achieved that, right? So add controllers for CPU throughput, add shelves for disk and spindles. What happens is, in this case, if we're going from a 2-node, 4-node, 8-node, right, the performance profile is linearly going up, and that's one of the key things that we wanted our early access customers to test. And all our early access customers has verified and confirmed that, yes, as I'm adding node, I do see a very, very linear performance increase, which helps them a lot, which they liked. Right?
Sorry, is 2 the minimum size of nodes that you need to have, or?
So from an offering point of view, 4 is the minimum, right? From a technical point of view, yes, 2 is ONTAP capability can handle 2, but from an offering point of view, 4 is the minimum. because we want the increments of 2 after 4, right?
Okay.
Okay. Improved efficiency. This revolves around the new architecture of single pool of storage, like we said before. All nodes now see all drives, right? And this provides a lot of efficiencies in terms of how you use and manage space, right? So the notion here is what we wanted to do is, and the goal is, have the performance of RAID while having the efficiency of erasure coding, right? So we want to have more resiliency with lower overhead. We have implemented something called a zero copy vol move, since now we're talking about a very large container, right? So that, within the cluster, when the vol move happens within the AFX, they're all zero copy vol moves, which is also very, very effective when we're handling with failure scenarios. Let's say one node fails, then because we have this capability in the background, right, we could efficiently move that connection of that volume to a different neighboring node dynamically. Exactly, we're just moving the connector, we're just moving the pointers, right? So those will be the benefits. Operationally, it's very, very simple, because now you could dynamically add both compute and capacity separately. So space management now is much easier, because you do not have to say, oh, is this container or shelf a part of node 1 or node 2, node 3? You don't have to do that. It's all in one pot. So it's very, very easy to have that top view of, oh, is this much? I have this left, right? And then these are the volumes here and there, right? It's very, very easy in that sense. And also, of course, no aggregates to manage, right? Also, a lot of automation has we put in for managing this. So ONTAP now manages the RAID groups and all the other things kind of automatically, right? So that the eventual goal is when a user adds in more capacity, it should be just automatically added in, and it should utilize that empty space that was just added in appropriately, right, and optimally.
To go to Guy's question before, though, that first bullet under single pool of storage is the use case for the small 2-node. Why, even on the smaller side, those customers typically don't have the expertise to manage storage.
Correct.
So any way you can make their life easier, so they don't have to worry about an aggregate on node A, aggregate on node B. If they just had that, I think that would also be good under the small scale. So,
that is good input.
I also say, I'm going to make some assumptions here, and you can correct me if I'm wrong, but the assumption that you've removed the root volumes somewhere, they're in the compute nodes somehow different, because that was a...
Root nodes are tough.
Yeah, that's always been a tough thing in the...
Root vols.
Yeah, the root vols and everything else, that's all been really tough to handle in the traditional HA stuff, right? So make the assumption, and maybe you'll cover it later, but that's gone. But having that gone, with the automatic space management, RAID group definitions, and all of that stuff, I can see a real interesting place for this in the smaller end.
Gotcha.
Because designing, ADP was great, but it was a sticking plaster. And so, removing things like that make, just for the smaller systems as well, the storage admin's job so much easier. I can see the amount of time that went into architecting and balancing systems and doing performance and migrations and other things.
For lower end, for lower cells, for lower revenue.
Yeah.
And it causes your support organization headaches as well.
Yeah, exactly. So there's a huge future there for replacing some of that.
I think that's good input. Yes, makes sense. All right. Data mobility. So let me just build this out. Right. In terms of data mobility within the cluster, we utilize all data mobility features on ONTAP because it's running the same ONTAP. Now, these kind of data mobility capabilities have a different meaning because now we're dealing with, again, such a huge single pool of storage. So things like vol move is going to be much, much more heavily used by our customers and by the system itself, right? Like I mentioned, flexibility in node failure scenarios. Before, right, on an HA pair, if one node fails, then yes, you have to kind of accommodate that 50%, up to 50% performance loss. But on this side, since it's disaggregated and you may have 8 nodes and one node fails, then it's not a 50% because we could shift the pointers on the volume in this case, so that all the other nodes can participate and assist on that down. So it's not a 50%, it's minimized in that sense, right? We're also making more enhancements on our failover capabilities, and we'll kind of, you'll see the enhancements as our AFX releases kind of go on. But right off the bat, these are the benefits that we will be providing for our customers. Simplified expansion, the scenario of adding a node is very, very simple. You add a node, the system will detect it automatically, and it will not add it in because the system administrator may want to have a separate cluster or whatnot. So it will discover it and tell for a system manager that, hey, I discovered these nodes, AFX nodes. Do you want to add it or not? If so, okay, add it in. Off you go, right? Similar with capacity, but more. So capacity is more of a, when it's added in, yeah, it automatically detects it. Like I said before, it automatically adds it to the single storage pool, and it will automatically load balance once it's added in.
Do all the nodes act as a single global namespace?
Say that again?
Do all the nodes act as a single global namespace?
That depends on how you configured, right? If you have an AFX with, 2 petabytes, and you start putting in a bunch of flex vols, which are in its own container, then no. But if you have a flex group that spans across the whole AFX system, then it's a single global namespace in that sense, right? Now, outside of the cluster, then we have other technology and capabilities like flex cache and whatnot that will expand that global namespace to other data centers or other clusters or other nodes for that matter, right?
And how are we kind of load balancing or organizing connectivities into the many nodes? If I've got 200 storage nodes, what is it, DNS round robin or some form of BGP, or like how do we connect in?
You want to take that?
So today is DNS load balancing. We are looking into OnBox again. I mean, there was a time when we had it, but there were some challenges with it. That's an interesting idea about BGP, right? That's another technique we are looking at to even like consider like moving an individual volume from one cluster to the other, right? Yeah. I think these are in progress actually, but not there yet. But for now, I think our recommendation stands, which is DNS load balancing, right? And many of our customers prefer off-box load balancing because they do load balancing at a data center level, right? They have built mechanics into that to use distribute the load across clusters and everything too, right?
Yeah. Just interesting that there's some similarities with some of the ways that storage grid, and we have the load balancer nodes in front of them, and it's is there a potential obviously providing something for S3 AFX in the future?
Correct. For S3, I think there's a good possibility, and it's being stateless, right? In many ways, there's a good possibility to do something like storage grid, right? But for now, we are leveraging the off-box. Yeah.
Okay.
Next is yours.
Okay. All right. It's really hard to explain architecture with marketing-looking slides, right? But I'll try my best. So if you think through what it is today, right? I mean, there's a set of clients and data network, and you know our familiar protocols, right? If you look at what I'm showing here is a unified architecture, right? Which is our 30-year legacy, right? We have file, object, and block. We had a HA pair. HA pair was a domain of operation for the aggregate, right? Aggregate is a collection of disks. And that actually where you used to provision volumes explicitly, right? So if you have to move data or balance data, then you have to actually move from one aggregate to the other. Backend network, was provisioned for cluster network VLAN and cluster, even all the HA pairs are connected to the cluster VLAN, right? We could scale up to like say 24 nodes, right? In some specific cases, we have done 40 nodes, but with AFX, we're going to go a whole lot of big, right? We used to, so pay attention to the color as I can represent the aggregates. And specifically, I'm representing the modular systems we have today out there, right? Which are like, where disk and storage are connected by the network, right? And in this particular case, you can see, even though they are connected by the network, right? But the islands of storage were created for aggregates and connected to the HA pairs. And these are the differences with AFX architecture, right? I'll probably go through one by one so that we can follow through. Now we have a storage VLAN, which actually effectively a separate network for storage as well, right? We are trying to consolidate that as well for reduction of cost. So there was a great question about, hey, are we really done? Can we pivot to, that could be the central storage for everything, right? We have to really look at for some workloads, like for example, 2-node clusters with no switch, right? There are a lot of deployments there, right? We have to really look at it and say, hey, does this architecture help with the cost model of that, right? Today we can't see that, right? But as we look to the next generation of platforms, that's our focus, right? How you get into mid-range and low end and etc., right? So interesting thing about this disaggregated ONTAP is hardware. We didn't plan for hardware and software to release at the same time. Meaning in the sense of we didn't have a new hardware to play with this, right? We took what we released for unified ONTAP, which is A1K, 8000, and we actually use that as a foundation for developing disaggregated ONTAP. So it may not look great today in terms of the density and everything, but at the same time, now that you have a software architecture that actually can disaggregate, it feeds into the next generation hardware discussions, right? Which actually can help us get to the best price, performance, and density. Right? Even knowing that, we still optimize our A1K platform, and we call it AFX A1K for a reason, because we had to make some modifications to the hardware for better performance, right? The other aspect is like shelf. For the first time, I would say at least I've been at NetApp 21 years, right? For the first time, we had to pay attention to the shelf performance, because now every node is sharing is connected to the same shelf, right? And what that means is that performance of all nodes hitting the shelf at the same time can actually requires more bandwidth. Modular systems, we didn't have to worry about that. We have only 2 nodes connected to it, right? So some of these critical differences come into play, to answer that question. Hey, are we ready fully for making it mainstream for every workload, right? So it's probably going to take like a few years before we get there, as we look at unified and all the use cases and move there, right? For now, the focus is AI. And when I say AI as an engineer, for me, the focus is throughput, right? It's very optimized for throughput architecture, right? It's flex group,
That also makes it incredibly useful for EDA and HPC, right?
Absolutely, absolutely, yeah.
And
Seems
media
like
and entertainment.
Yeah, well,
Every workload.
But
If you really,
anything that needs real high performance in
absolutely.
a lot of work in EDA is really performance restricted.
No, absolutely. Every workload, as you know, right, and has phases of different I/O operations, right? And one starts with latency sensitivity, then data management, and then you get to throughput, like tape outs and everything, right? But we're optimizing from the other end here, right? But still leading with all the features, right? Our intent is firmly to support all the workloads, right? But today the focus is AI, right? Because that's where the biggest demands are. And another way to look at it is that, hey, AI is going to be in front of every other workload, right? You can consider it a vertical or a horizontal. To me, it's a horizontal eventually, right? Because inferencing is going to be part of every workload.
Oh, it's a horizontal now. Yeah. I stopped saying it lately, but hey, this is a great chance to say it again. AI is not might be a workload. No, it's not an application. People talk about AI applications. The applications are the applications. AI, multiple AI, hundreds, thousands of AI, including agents, are being exposed and should be exposed as services that can be picked up, whether ad hoc or integrated by applications.
That's scale for us. So the way you're saying it, that's scale, right? I totally agree with you, right? I mean, I was probably one of the first ones who used to say that this is actually horizontal more than vertical. But as a storage company, it always starts as a workload because it's easier to identify in terms of requirements, right? And then we bubble it up, right? In terms of app integration like AIDE, et cetera, right? So we don't support block today, not a surprise. All nodes share the same disks. I think it's a very important point. And no individual node owns a particular set of disks, right? It's all abstracted under when we create that aggregate pool. A single pool of storage is what we call it. There's a certain layout we follow with certain data disks and parity disks, right? For RAID configurations, the configurations will keep changing as we expand the capacity pool. And HA is connected by the Ethernet switch. So HA network, HA goes over the network. I think so. To go back to the point I made about, hey, we took what we had for unified ONTAP A1K and we supported it with AFX. The HA actually had to be put on the network, right, for that. And what that means is that eventually we get to NV HA where 3-node failures, or 2-node failures, 3-node failures will be absorbed by any node in the cluster, right? That also helps us actually remove that constraint of, hey, planning for headroom, 50% headroom, if there was HA failover, right? We don't tout that a lot, but but that's going to be probably a game changer for many customers who want to optimize cost performance in terms of the deployment, right? They plan for like 5 systems versus 6, right? Now you have that flexibility. Of course, compute and capacity are decoupled, and that's the whole point of disaggregated.
There's a lot of this all over RDMA.
Yes, absolutely. Yeah.
Was there thought of using anything else?
InfiniBand.
CXL,
Sorry?
like direct CXL or any of those newer?
We're looking at CXL, but our platforms don't today, right? Yeah. There's a consideration, I would say, right at this point. Yeah. And if you ask NVIDIA, they'll tell you, NVLink, can you put that in there, everything in there?
Oh, they invested $5 billion into Intel to get it the chipset, right?
Exactly.
But we still have the concept where we have a volume that is owned primarily by a node, and that data will be served primarily by that node.
Yeah, I will say it's hosted on a node. Hosted on a node, because it's compute again. Yeah. So why do we have that volume as a concept? Because it's our way of enforcing data management and consistency. Right? You'll still have that volume as a concept. But I think you touched upon a question. I think I was tempted to answer, but I was holding back. I think you were asking a question whether that same volume can be accessed from other node, right? And as IP, another request comes in.
You could do today.
Yeah. So we are looking at some options where at least the read part can be optimized, where you still need write path to go through one node for consistency, right? Because they have to go through NVRAM or NVMEM, like in future. But reads can be optimized where I could instantly flex clone and then boom, like I can serve the read through their different node.
Can't you just do LACP across multiple nodes, make one virtual interface across nodes?
I know what you mean, right? And we could look at that, but I think there is some overhead there. In terms, I think it's probably say maybe maybe I mean as architecture we are optimizing for too much flexibility of not having to manage multiple entities, right? I think one good thing about at the bottommost point there, volume move to any node without copying data, we do that automatically today. So volume move as a feature existed in unified ONTAP for almost 25 years, 15 years, right? But we never moved it automatically. Customers had to manage it. For the first time, we are able to do this because we know exactly how the load is going to be perceived through nodes and be able to move.
Well, in your own words, you're actually doing a volume rehosting.
Exactly. Yeah. Actually, we have another operation called volume rehost, which is like reattaching across SVMs, but that's a different conversation. You're absolutely right. We are rehosting a volume pointer just so that the traffic gets routed to that, right? So because we could do volume moves automatically, right, without copying, clones also can be provisioned automatically to redirect data right across, right? I think probably given the time, I think I'll probably skip through that, but I think I just covered that IO path, how it works, right? So volume is still there, IO path still goes through that today. Reads will be optimized out where it can be served from any node. Writes actually will definitely have to go through one node, right? But if you have a flex group, your data is distributed across all volumes, right, technically.
So this is where CXL would make this so much better, because you'd have rack scale access to the NVRAM directly, and so you could write from anywhere.
Yep. So sharding.
It's not high enough to make it workable.
Sharding memory layer, NVRAM layer across all the nodes, and being able to reach consistency point through any node. I think that's where you're getting it. Yes, makes sense. Yeah. So when we are looking at NVHA, we are considering that, by the way, right? We are looking at, so today for us, the nodes are stateful, right, in some sense, because NVRAM is attached to that and consistency point is driven through that. If and when we get to statelessness, I think there are some other options available. Probably skip through fast. And we talked about compatibility, right? I think we take this seriously. So there were a lot of questions about, okay, hey, should I move my data from existing data asset to this one? Yes. I mean, there's no sugarcoating there, right? You have to move the data, right? But reality is that, hey, we changed the entire aggregate layer. The storage layer completely has changed. It aggregated all nodes into single storage pool, and that's why we really cannot just in place upgrade existing systems into that, right?
And the existing systems include other ONTAP systems.
Other ONTAP unified systems, right? Yeah. When you have the next generation of AFX systems, I think, yeah, you could tech refresh them. You can bring them in node, and then you can just refresh them out, right? But existing unified. So realizing that could be an issue for some customers, I think we made sure that the data mobility features that we have customers have loved over years are supported from day one. Everything is supported today, right, on day one. So none of the features had to be recoded for this architecture, and that's the beauty of the layered architecture that ONTAP is, right? We just have to make sure the RAID layer had to be converted to the single pool of storage. I should not oversimplify it. A lot of engineers won't like me when I say that, but I think, but we were able to pull that through without changing anything at the data management layer. You will see secure multi-tenancy storage virtual machines that we have supported for last 15, 20 years, which I think is some neoclouds are actually very interested in because they require NCP certification, and neoclouds require secure multi-tenancy actually built into the storage. So they're hosting multiple customers onto the same infrastructure. It's a great feature. All the security features except aggregate encryption will have volume level encryption, flex group or volume level with your own keys. Snapshot, snap error, everything will work. Flex group, flex wall, flex cache. There was a question about, do we always have to copy data from existing unified assets into AFX? No, not necessarily. You can burst with flex cache, do your training, do your whatever, right? And I talk to neoclouds all the time, and one of the things they say is that they always segregate architectures into somewhat of an inner ring and outer ring. Inner ring being for in training, outer ring is where they have all the copies of data, actual data, right? And all they want is burst and do training and then leave it, right? Flex cache is a great story for that. Right?
Still technically moving data, though.
Only portion of data you can.
Right.
Oh, yeah, still moving data, yeah. I mean, to me, storage is all about managing cost performance and...
I'm not complaining about it.
Yeah, exactly. Yeah. No change in the way any of the protocols operate, volume ownership on single node, right? We talked about it, and none of the APIs or anything like that change. I think one of the great feedback we got from our customer base, our brownfield customer base, who have been longing for disaggregated storage for some applications, actually even in EDA, for example, where they care for EDA simulations, they care for less capacity, more performance. They really loved it, and as I said, that boom, like we planned for early access program of 6 weeks, but they were done in like 2 weeks because all the APIs worked as is. That's the beauty of this. There are a couple of features missing, and I believe I kind of alluded to that. One is a fabric pool, which enables us to tier data to object store, right? Is being worked on. Drive mixing, I think it's in progress. We are mixing drives in our unified ONTAP, and here we have a strong journey to get to 120 terabyte SSDs in a matter of like 6 months, 6 to 9 months. There's a whole lot of things happening, right, with this architecture. This architecture makes a lot of things possible independently, right? While we improve our standing in terms of the controller roadmap over time, like high and mid-range and everything, we can actually address the workloads where capacities, exabyte level capacity deployments are actually could be a norm, given that AI and they want to get all the data assets into single infrastructure, right?
Yeah, having fabric pool missing, and we're not getting to AIDE yet though, but as you start storing embeddings along with your data,
Yep.
and then you change embeddings or update embeddings, you have to re-embed everything.
Correct.
To take the old versions, either you have to keep them,
Correct.
snapshot, so you're going to have
It's going to be a whole lot of
fabric pool loads
absolutely,
off.
absolutely. It's been actively worked on, and you should see that in the next 6 to 12 months. I think I've covered all these. I don't know if I have anything specific to cover. Yeah, RayTech, we leverage RayTech for reliability of data, and actually we're going to increase the size of that. 93 becomes 126, 3P becomes 6, right? So this allows us to actually scale to that level, right? My point is having aggregate constraint to HA pair, we never needed these things, but now we have to work on that. Yeah, so again, moving to disaggregator ONTAP today is not required for customers, right? But it's a start. If somebody is planning for a new AI infrastructure, this is what we would recommend, right? Or other verticals as well, right? There's nothing stopping us from deploying it. Unified ONTAP is not going anywhere. I think our goal, like what we have done in hybrid cloud scenarios, our goal is to connect wherever your storage is, right? And we take that seriously, right? Changing data management layer and above is not an option. And that's what we have done here, right? That's why we have been able to get to this market faster. I think it's probably a year of 2 evolution where this will be ready for everything. And this is an engineer speaking, so don't hold me to it.